Welcome back. Let's continue building our monster battle simulator in C++. Just a quick recap. In the previous episode, we gave our game the ability to let the player choose a monster and give it a name. But right now, those choices don't actually matter. That's because our game only remembers the number we selected and the name we entered. It doesn't know that 1 means dragon, 2 means wolf, 3 means slime, or 4 means golem. Today, we're going to change that. We will teach our game how to make decisions using these secret ingredients. Let's start coding. We'll add this code right after the player selects a monster. But wait, does the placement of this code matter? Absolutely. When we run a C++ program, it executes one line at a time from top to bottom, starting inside the main function, just like reading a paragraph in a book. Now let's break this if statement down. This is called an if statement. Inside the parenthesis is a condition. We read this condition like a question. Is selected monster equal to 1? If the answer is yes, this condition is true. So C++ executes the code inside these curly braces. If the answer is no, C++ simply skips this block. Alright, let's test it. Perfect. Since selected monster is equal to 1, the condition becomes true, so the code inside the if statement runs. What if we choose a different number? This time, the condition is false, so C++ skips the if block and executes the else block instead. Our code works. And now our game can recognize which monster the player selected. But there's a problem. Right now, our game only knows about the dragon. What about the wolf, slime, and golem? That's where else if comes in. Think of else if as asking a follow-up question. If the first condition wasn't true, C++ checks the next one. If that condition is true, it runs that block of code instead. C++ checks each condition one by one from top to bottom. As soon as it finds one that's true, it executes that block and skips the rest. And for the else part, since we only have 4 monsters, any number other than 1 through 4 will print this invalid input message. Alright, let's test it. Great! Let's try an invalid input. Did you notice that? When we entered a number outside of 1 through 4, it correctly showed the invalid input message. But it still asked for the monster's name. Well, congratulations! We just created our first bug. Let's fix it. Since the input is invalid, we don't want the program to continue. So we'll use return 0 to end the program right here. Okay, let's verify it. Well done! Our game can finally make decisions based on the player's choices. Choosing a monster now actually matters. Hold on, will I actually remember what this code does next week? Probably not. That's why C++ has comments. Just like many other programming languages, C++ also has comments. Comments let us leave notes for ourselves or other programmers. The compiler completely ignores them so they don't affect how our program runs. For example, I can leave myself a reminder. As our program gets bigger, comments become even more useful. They help us organize our code and remind us what each section does. That's why you'll often see comments in real-world projects. We're finally going to cross this to-do off the list. We'll organize our code into functions and begin our monsters adventure. If you're enjoying the series, consider subscribing. See you in the next episode.